Precious scholars, welcome once more to our platform. I want to thank you for finding time to join us in spite of your crowded schedule. Don't forget that in this series, we have been discussing indices. And I must say, I tremendously appreciate what you are doing with the videos. Thank you for liking them, thank you for sharing or reposting them, and thank you for your subscription to our channel. We can assure you that more impactful and explanatory videos will continue to come. In the last two videos on this series indices, we discussed the meaning of indices, where we said it is the plural of index and that it provides cheap and simple techniques for solving mathematics that involves characters or mathematical terms. Then we went ahead to look at the 7 laws of indices. What we want to do in the next 2 series is to look at the applications of the 7 laws of indices to solving real life problems through examples. Let's take example 1. Example 1. Show that a raised to power 0 is equal to 1. Show that a raised to power 0 is equal to 1. Don't forget that this is the kernel of the 3rd law of indices. So how did this law come about is what we want to show now. Look at our simple answer. It's a simple one. Don't forget that the difference, the outcome or difference of subtracting a number from itself is 0. So it means therefore that when we say a raised to power 0, we could rewrite it as a raised to power n minus n. So you may rewrite it as a raised to power n minus n, a raised to power q minus q, because n minus n is 0, n minus n is 0, q minus q is 0. Then from the quotient law of indices, a raised to power n minus n is the same as saying a raised to power n divided by a raised to power n. Why? We told you that division of the terms lead to subtraction in the index. So it means that subtraction in the index will lead to division of the terms. And so this is saying a raised to power n divided by a raised to power n. It's like say 1 divided by 1, or 2 divided by 2, or 3 divided by 3, or 4 divided by 4. And you agree with me that 1 divided by 1 is 1, 2 divided by 2 is 2, 3 divided by 3 is 3, 4 divided by 4 is 1, 3 divided by 3 rather is 1, 2 divided by 2 is 1. It therefore means that a raised to power n divided by a raised to power n is equal to 1. Which is what we set out to show. We can therefore conclude that a raised to power 0 is equal to 1. Let's look at example 2. Example 2. Simplify. Simplify 3 raised to power 1 minus n times 3 raised to power n minus 1. Answer. We want to simplify 3 raised to power 1 minus n times 3 raised to power n minus 1. You notice that in this second example, the index in the first term is 1 minus n, while the base is 3. The base in the second term remains 3, but the index has changed to n minus 1. But because both terms are separated by multiplication, it means that we are using the product law. So we now have 3 raised to power 1 minus n times 3 raised to power n minus 1 equals, the law says pick the base, which is 3, then add the indices 1 minus n plus n minus 1. This will give us 3 raised to power. All we need to do now is to rearrange the indices. So we have 1. The next that will follow it is minus 1, then plus n, followed by minus n. And this will give us 3 raised to power 1 minus 1, 0, plus n minus n, also 0. And what is 0 plus 0 is 0. What is 3 raised to power 0? Don't forget that by law number 3 of indices, any number raised to power 0 is 1. Therefore, 3 raised to power 0 will give us 1. It follows therefore that 3 raised to power 1 minus n times 3 raised to power n minus 1 is equal to 1. We'll move yet to the third example. Example 3. In example 3, let us simplify 3s raised to power 5 times 2s raised to power minus 3 times 5s raised to power 8. Answer. It is a question that borders on indices because of the presence of these mathematical terms or characters: s raised to power 8, s raised to power minus 3, then s raised to power 5. We are going to attempt the solution to this example in 2 ways. We are going to use 2 ways. Let's take the first method. What we have is 3s raised to power 5 times 2s raised to power minus 3 times 5s raised to power 8. 3s raised to power 5 is the short way of writing 3 times s raised to power 5. In the same vein, 2s raised to power minus 3 is the short way of writing 2 times s raised to power minus 3. And finally, 5s raised to power 8 is the short way of writing 5 times s raised to power 8. We can now rearrange, let the constant numbers come together, then let the letters take their own course. This will give us 3 times 2 times 5, then times s raised to power 5, times s raised to power minus 3, times s raised to power 8. 3 times 2 is 6, 6 times 5 is 30, times, then use the first law, the product law of s raised to power 5 times s raised to power minus 3 times s raised to power 8. That will give us s raised to power 5 plus the next index minus 3 plus the next index 8. But because we have 2 signs, plus and minus, separate them using brackets. Having done that, the next line becomes 30 times s raised to power 5 plus times minus 3 is minus 3, then plus 8. 30 times s raised to power 5 minus 3 is 2. 2 plus 8 is 10. 30 times s raised to power 10 is the long way of writing 30s raised to power 10. Therefore, 3s raised to power 5 times 2s raised to power minus 3 times 5s raised to power 8 is equal to 30 s raised to power 10. I hope you are getting the nitty-gritty of the application of the laws of indices to solving real-life problems. We are going to continue in the next video, but in the meantime, continue to like our videos, share them, and continue to subscribe. Thank you.